Hello everyone, welcome to my channel. In this lecture we will discuss about the pump. A pump is used to pump liquid water at 1 atmospheric pressure and 25 degrees C to 3 atmospheric pressure. The question is, what is the outlet temperature of the pump and what is the efficiency of the pump using the Aspen Hysys simulation. So we will use Aspen Hysys software and we will determine the outlet temperature and efficiency of the pump. So first of all, come to the Aspen Hysys. Open Aspen Hysys version number 10. First of all, we will select the component list. After that, we will select the fluid package, and after that, we will come to the simulation. So first of all, we will select the component list. So we will go to the add option. Click on add. So these are the various components: methane, ethane, propane, isobutane, normal butane, isopentane, normal pentane, hexane. These are the various components. And this is the formula. These are the formula. You can also search the component in this list, in this space, in this box. So I am searching liquid water. So water. Water. You can add. After that, we will select the fluid package. So we will select the fluid package. Click on fluid package. Now click on add. These are the various fluid packages: Antoine equation and RTL equation, Phil Robinson equation, upstate, SRK equation, Sawyer Ripley-Kong equation, Unique, Wilson Unique, and these are the various equations. So I am using the NRTL equation. So I am using the NRTL equation. So NRTL equation. Now this is okay. Property package is okay. If this color is red or yellow or some other color, then our selected fluid package will be incorrect. In this case, this box is green. It means that our selected fluid package, which is the NRTL, that is correct fluid package for liquid water. So if our fluid package is incorrect, we can select other fluid package from this fluid packages box. So the third step is come to the simulation. Click on simulation. The simulation environment. This is the stream. This is the material stream. This is the energy stream. And these are the various component: external mode, heat exchanger. These are the heat exchanger. And the separator, pressure changer, reactor, separator, etc. So I am using the pump to pump liquid water. First of all, I will select the two material stream: the inlet water and the outlet water. So the inlet water and outlet water are the material stream. These are not the energy stream. So the material stream is this one is the material stream. If we click on it, it shows material stream. This is the energy stream. So click on material stream, drag it. Now double click on it. This window will open, and this shows the stream name, the vapor phase fraction, the temperature, the pressure, the mass flow rate, molar flow rate, etc. So the stream name is inlet. So I am clicking on it. Inlet to the pump. So inlet. The temperature is 25 degrees C. Temperature is 25 degrees C. This is the degree C. 25 degrees C, and the pressure is 1 atmospheric pressure. So 1 atmospheric pressure. So 1 atmospheric pressure. 1 atmospheric pressure is equal to 101.3 kilopascal. And the mass flow rate or the molar flow rate. The molar flow rate is, we assume the molar flow rate is 100 kilogram mole per hour. So 100 kilogram mole per hour. 100 kilogram mole per hour. So I'm assuming the 100 kilogram per mole. 100 kilogram mole per hour is the molar flow rate. The molar flow rate is 100 kilogram mole per hour, which are flowing in the pump. So these are the now the second step is the property composition. Now come to the composition. Click on composition. Now this is the empty, so the mole fraction is 1. So it is pure water having the molar flow rate 100 kilogram mole per hour. So this is 1. Water is 1. So mole fraction is 1. So this is the mole fraction 1. Yes, this is 1. Click on OK. So our two stream is specified. Inlet stream is specified. Now close it. Come to the outlet stream. Click on it and drag it to here. Click on it. Now double click on it. So this is name it. This is the outlet stream. Outlet stream. So we can name it outlet stream. Outlet. And the temperature here is unknown. We are going to determine the outlet temperature of the pump. The pressure is 3 kilopascal, 3 atmosphere. So 3 atmosphere. So come to the atmosphere. It is equal to 304 kilopascal. The molar flow rate is same. Again, it is 100 kilogram mole per hour. And the composition is also same. The outlet water composition is 1 pure water. So we click on OK and close it. Now the one this is specified, this stream is specified because its color is blue, dark blue, and this is unspecified. If we can check it from its color, so the color is this. These color are different. So if the color is like this color, so it will be completely specified. If the color is this one, then it means that it's not fully specified. So this is fully specified, and we are going to determine the outlet temperature of this stream. So the next step is come to the pump. This pump, centrifugal pump. Click on it, drag it, and this. Now double click on it. This window will open. So this window will open. Now required a feed stream. These are the required feed stream. These are the inlet, outlet, energy stream. So the inlet stream and outlet stream. So this is the inlet stream which we have already specified. So click on it, inlet, and the outlet. This is the outlet. Energy. So energy of the pump. You can say anything. Pump work of the pump. WP, pump work. So it's okay. This is okay. Now it's okay. Now if this is the parameter, these are the curve. This is the rating, worksheet, performance, dynamics. So worksheet, this is the rating, and this is the worksheet. So if you from the worksheet we can see that the outlet temperature of the pump is 25.02. So slightly increased. The outlet temperature is slightly increased. This is the outlet temperature of the pump. So this is the outlet temperature of the pump. Now we can also determine the efficiency of the pump. So this is the composition design. Come to the designing. These are the parameters. So this is the density of the pump. So we can add 0.13 kilowatt energy to the pump to pump the liquid water from 1 atmospheric pressure to 3 atmospheric pressure. Now, and the efficiency of the pump is 75%. So the efficiency of the pump is 75%, and the outlet temperature of the pump is 25.02 degrees centigrade. So this is our requirement. Now we can also change the efficiency. So if we change the efficiency to 90 degrees centigrade, then what will be the duty of the pump, it is changed. Now it is changed, and if we see the output temperature, we see the outlet temperature. We see the outlet temperature. So the outlet is the inlet, and this is the outlet. This is the condition. So if we see the outlet temperature, it is 21.01. It is slightly changed. So we can either change the outlet temperature or efficiency, and we can determine the other parameter using Aspen Hysys. So we can close it, and this is the simulation environment. By default the pump name is P100. We can change it also. So this is the pump. We can change it also, or so this is the okay. Now this is the inlet. We can close it. Outlet and the inlet. Now we can add the material and energy stream table. So click on this, right click, this window will open. Come to add work table. Add work table. These are we can add material stream, composition, energy stream. So if we are going to add material stream, click on material stream and select it. So this is the material stream. So the temperature is in degrees centigrade, pressure in kilopascal, inlet temperature is this one, outlet temperature of the pump is this one, the inlet pressure is this one, outlet pressure is this one, molar flow rate is this one, and the mass flow rate is this one, the liquid. This is the cubic meter into per hour volumetric flow rate. So heat flow, and we can add the energy stream. Come to the work book table. Come to the composition. We can also add composition. Select on it composition. So we can also add this composition. The composition is inlet and outlet composition of same because it is pure water. Come to add workbook table. Add energy stream. Click on energy stream. Click on select option. So this is the energy stream. This is 402 kilojoule per hour is the energy flow rate. So the energy flow rate is this one. So the energy flow rate. So this is all about the pump, simulation of pump using Aspen Hysys. Thank you very much for your attention. If you are new to the channel, please like and subscribe.